Hello everybody and welcome to another video of mine. Today I wanted to talk about time. Why? Because I had a reading competition at my school and the piece I read was about a dying child. This is the book. I have a link in the description in case you want to read it or know more about it. Now, in the video there is a dying child that has only a few days to live, and it wants to know as much as possible about the world that it lives in and how it works. Now, at the end of the piece, it has its last chat with its father, who has been with her the whole time, and they talk about the chicken egg problem. And this girl, this dying child, it isn't really explained if it's a girl or boy, found a wonderful explanation in that last chat. And this whole story made me question a lot of things, but most importantly I wanted to know what time is. After all, the chicken egg problem the girl found a so wonderful explanation to, which is about the question what was first, chicken or egg, is only possible in a universe with time. And if you really think about it, you finding a good answer for this question, what is time, is really difficult. I want you to pause the video for a short time and think about it yourself, and I don't want you to come up with an answer like time, it is that thing hanging there on my wall. So I want you to pause and think about it for a sec. Welcome back 5,000 years later. Don't worry, it is really hard to find an answer, and that's not the reason why you came here, isn't it? You came here to see what I have to say about it, and maybe then you would know a little bit more about what even is time. So, as I always say in my videos, let's get right into it. At first I only wanted to know what time is, but after I had asked a few people about it, I realized that apparently nobody truly knows. I either got a shrug of the shoulders or some kind of waffle where it was tried to explain the word time with the thing itself, and this wasn't really something I considered an answer. Obviously the answer to my oh so simple question was anything but simple. The worst answer came from one of my teachers, who actually told me to wait for the next grade, which is to say when I will have left our basic school and will have gone off to extended school. Then I should just repeat the question to the teachers there. Some people even looked at as if asking the very question is something one does not do. I almost felt like committing an original sin when asking, what the heck is time? So I asked my father. If truth behold, I had already asked him before, but then he had said that I should try and do my own little research before bothering him with such horrible complicated questions. At the time I could not understand what was so darn horrible regarding the question, but after all, it was just about such an omnipresent thing like time. But when I asked my father why my question is so horrible, he simply said, "You will see." And just as explained, see, I did. When telling my father about the question I got from one of my teachers, he even laughed and said that this could at least count as an honest answer, even though it was more of an excuse than an answer. Then he told me about an old calculation where he had found that time apparently appears quite automatically when subjection an arbitrary ensemble of properties to a minimum principle. This started to sound interesting, but also a bit complicated, and so I prepared for a long, hard slog. At first my father showed me how a German mathematic named David Hilbert had used so-called variation integrals to formulate things as extremals. He explained that it does not matter what set of properties one considers. The moment these properties form a space, they can be thrown into such variation process, and the results are the governing laws of the system containing these properties. This may sound a bit complicated, but in essence it just says that the ball always tries to roll in the valley and would not like to rest on the hill top. Now you generalize this concept to arbitrary systems with many dimensions, and you have the Hilbert variational integral. The next step is a bit of very tricky calculations, for which I do not understand more than the whole variational integral is being reshaped, so that we obtain the structure on the bottom. This is still a variational integral, but one which, at least so my father says, can be treated more easily than the stuff we had before. In sufficiently simple spaces, the result of the whole variation is something I immediately recognized from one of my earlier presentations, where I have tried to illustrate a Schrödinger solution in exactly 4 dimensions. Surprise, surprise, the whole result simplifies to a very simple equation, which mathematics call a Laplace equation. Thereby the Laplace operation, which gives the equation its character, is the triangle which acts on the function f. This already was quite some math, and I have to admit that I'm totally lost with this kind of stuff myself, but it suffices to know the result, which is to say the Laplace equation. For this we only need a little bit more digging. Thereby we will not need further math, but simply have to know that in simple flat spaces the Laplace operation we have just derived always demands at least one coordinate to become time-like. In other words, while scientists like Einstein have postulated the time and thus created the concept of space-time, we see that time does not need to be introduced, but falls out of the fundamental laws of our universe. With this finding, however, we have to say goodbye to the idea of an omnipresent fundamental time, which somehow fell out of the sky. Time is a part of a very principal solution, and our fate is to live on that very solution. And I thank you all for listening.